Hey, good morning, Panthers. I'm sorry that I'm not in the room with you this morning. I am actually in the building, but I'm attending a meeting in another part of the building, so I'm not able to be with you today, but we will carry on as usual. Panthers, by now, you should already have your whiteboard marker and eraser ready to go. We're going to practice this morning. In just a little while, you'll take the mastery assessment for learning targets 30, 31, and 32. Before we start talking about factoring, I will tell you that we will not be doing Secret Panther today, but I'll make it up to you tomorrow on Thursday by making sure there are 2 Secret Panthers, okay? So you won't miss out on that opportunity to win the donuts. We just won't be doing it today. Hopefully Thursday's a win, and I can be bringing you donuts Friday morning. That would be fantastic, Panthers. We're going to talk about the GCF, the greatest common factor, learning target 30. But I wanted to show you first some general reminders that factoring means to write the given expression as a product. This is very important, Panthers. The part of this problem that we are struggling with is this part right here, the make sure your answer looks like a multiplication problem. That's something that we have to do just a little bit better, Panthers, okay? So we will practice that in just a moment. To find the greatest common factor, the GCF, find the largest monomial that is a factor of every term. It's got to be in every term. If it's not in one of the terms, it doesn't count. And then find the other factor by dividing out the dividing by the GCF rather. Let's practice that for just a second. Okay, so Panthers, here's a problem that's like what's on today's mastery assessment. On your whiteboard, consider the polynomial 3a to the 6th minus 15a to the 4th plus 12a to the 7th. I want you to find the greatest common factor and then write the polynomial in factored form. I'll give you a couple minutes to try it. We'll pause and we'll go for about 3 minutes. Maybe, no, I'm sorry, not 3. Let's do 2. 2 minutes. And then we will hit play and we'll look at it together. Okay, Panthers, the greatest common factor. The thing I would do if I were you is I would work upon the coefficients separately from the variables. I look at the coefficients. I look at 3, I look at 15, and I look at 12. And I'm trying to find the biggest number that goes into all 3 evenly. If you don't see it right away, take the smallest of the numbers and list out all the factors that divide into 3. In this case, 1 and 3 is the only option. And now work your way backwards. Start with 3. Does 3 divide evenly into 15 and 12? If the answer is yes, then that's part of your GCF. 3 is part of what I need. Now we've got to worry about the A's as well. I've got to decide, is A in every term? The answer is yes. So what I'm looking for then is the smallest power of A I see. And I see that right here. So I need 3a to the 4th. That should be my greatest common factor. That's the GCF. That's the first part. To write it in factored form, now we're thinking about making a multiplication problem. Okay. So what could I multiply 3a to the 4th by so that I get 3a to the 6th minus 15a to the 4th plus 12a to the 7th as my answer? And it's kind of like division. So as I work along here, well, what do I need to put here? What would you multiply by 3a to the 4th to get 3a to the 6th? It's just a squared. What about the next box? What would you multiply by 3a to the 4th to get negative 15a to the 4th? It's negative 5, and I don't need anything involving a. I've already got the a to the 4th. In the last box, what would you multiply by 3a to the 4th to get 12a to the 7th? I think it would be positive 4a cubed. And here's the thing that you've got to remember to do, Panthers. Write your answer like it's a multiplication problem. Write the 3a to the 4th times the other thing you'd multiply by, a squared minus 5 plus 4a cubed. That right there, that's what your answer should look like. Okay? How can you check it? You could multiply the 3a to the 4th by a squared minus 5 plus 4a cubed to see if you don't get back to the original polynomial, but check it out. The work is already there, Panthers. I want you to try a slightly different one, same idea. So take a look at this one now. Want want you to consider negative 12m squared n plus 18n to the fourth minus 6m cubed n cubed. Find the greatest common factor and then factor the thing. We'll give you 2.5 minutes this time. All right, Panthers, here we go. One thing I want to remind you of is that if the first term is negative, it helps to put negative in the GCF. You're not wrong if you leave the negative out. You can get the problem right, but there are things that will benefit you down the road in math where if the first term is negative, to make it part of the GCF. What I hope you discovered is that 6 is the number part, the coefficient part of the greatest common factor. I look at the m's, and I don't see an m in every term. That second term, that middle term, is missing the m's. So I can't include any m's in the greatest common factor. The smallest power of n I see is not 3, it's 1 right here. So n to the first, or n. The greatest common factor is negative 6n. Now, what can you multiply by negative 6n? To get negative 12m squared n plus 18n to the fourth minus 6m cubed n cubed. Well, let's figure it out. I think the first term I need a 2, and I already got the n. I need m squared. Quick check. 2m squared times negative 6n is negative 12m squared n. Here I think I need a negative 3. Negative 3 times negative 6 is positive 18. And I think I also need n cubed. I already have n, that's n to the first. N times n cubed is n to the fourth. And in the last term, I've already got the negative 6. That means I need a positive 1. I need all of the m's, m cubed. And I already have 1 n, I need 2 more n squared. And then make sure you write it as a multiplication problem. Our answer should look like negative 6n times 2m squared minus 3n cubed plus, I'm going to choose not to write the 1 in 1m cubed n squared, but it's okay if you do. There's our answer. Pretty good job, Panthers. All right, let's look at learning target 31, factoring polynomials. This is what we worked on right before spring break, Panthers. I want you to take about 3 minutes and see if you can factor both of these polynomials. We'll pause again. All right, Panthers, let's see how good at factoring you still are. You've done good work this week. We know to factor a trinomial, x squared belongs here. Here I need the plus 40 here. And I'm looking for what goes on the outside of the box. This is a simpler problem than what we've worked on this week. We'll practice that in a couple of minutes. But I know what goes outside the box here is x and x. I need to find the two numbers that I could multiply together to get 40. I'll list them out. I think that's all of the options there. And I want to find the pair that would give me negative 13 in these two boxes right here. And I think it's this one, 5 and 8. But what I realize is that to get negative 13, they're both going to be negative numbers, aren't they? I've got negative 5x and negative 8x, and that combines to negative 13x. So I've got it worked. All I need to do is remember to write the answer as a product, as a multiplication problem. X minus 8 times x minus 5. Good. Let's try the second one. Let's do a squared plus 3a minus 18. Well, in my box, I know where a squared belongs. I know where the negative 18's got to go. I believe I can tell you that I know this has to be a times a to get a squared. If you need to list out the factors of 18, you can. I've got 1 and 18. I've got 2 and 9. I've got 3 and 6, and I believe that's the whole set. And I notice since I need negative 18, one of those numbers will have to be positive and the other will have to be negative. So I'm really looking for the two numbers that have a difference of 3. Ah, here it is. 3 and 6. So this would be 3a, this would be 6a, and to get a positive 3a, I'll need minus 3 and plus 6, and I believe it works out. So what's my answer? Well, how about a plus 6 times a minus 3? Nice job, Panthers. Let's move on and look at a couple more items from last learning target. We'll take a look at these two now. We'll do the thing again where we will pause for about 3 minutes, and we'll give you a chance to try these two items. Okay, Panthers, something I hope you noticed on A is that the middle term is missing. So as we discussed earlier this week with a similar problem, I could rewrite that with a middle term of 0. That's the same as n squared plus 0n minus 4. I hope that makes it a little easier to know what to do to solve the thing. I've got n squared here, I've got a negative 4, and all I'm looking for in my middle terms now is plus 0. In other words, they need to cancel out. I'm going to get n and n here. My options for 4 are either 1 and 4 or 2 and 2, and they're going to have different signs. I guess I better pick the one that's the same number. Make a plus 2 one place, and a minus 2 the other. And sure enough, my middle terms give me 0n. That must be the factoring. Answer to this one must be n minus 2 times n plus 2. And on B, x squared plus 12x plus 36 looks like this. I'm looking for the two numbers that multiply together to give me 36 and add up to 12. Could be 1 and 36. Could be 2 and 18. 3 and 12 is an option, but it's not the one I want. 4 and 9 works, but that's not it either. 5 doesn't go into 36, but 6 does 6 times. You know what? That's the one, isn't it? That's the one. Plus 6 and plus 6. (6x and 6x makes 12x. We found it. There's two ways you could write the answer to this. One thing you could do is write x plus 6 times x plus 6. But another way, we talked about this a long time ago, is that if you got something times itself, you could also write that something squared. X plus 6, the whole thing to the second power. Either one of those answers is acceptable. You don't need both, but one of those will suffice. Panthers, that's the end of this first video, but we do have a couple more problems to practice on the next video that's coming up. Give us just a second to make the transition.